and welcome to Field Lab Earth, the podcast that's all about past and present advances in the fields of agronomic, crop, soil, and environmental sciences. Today, we'll be talking to Dr. Rebecca Nelson about the circular bionutrient economy. When nutrients are taken up in the field, they often find their way into the fruits and vegetables that we enjoy. But once we eat them, how can they get back to the fields for future crops? This episode, Rebecca will discuss her work in returning nutrients from human waste back to the soil. Rebecca will also be one of our plenary speakers at the Society's annual meeting this year. This year's meeting will be held in Salt Lake City, Utah, November 7th through the 10th, or virtually, wherever you feel most comfortable. The meeting features thousands of technical presentations, along with a host of networking events and award ceremonies. The world-class exhibition displays the latest scientific equipment, supplies, services, and reference materials available. I'm your host, Abby Morrison. Let's talk about science. Hi everyone, welcome to the show. Today we have Rebecca Nelson with us. Rebecca is a professor in the School of Integrative Plant Science at Cornell University. She co-chairs the Cornell Atkinson Center's Food Security Working Group and the Sustainable Agriculture and Food Systems Thematic Group of the UN's Sustainable Development Solutions Network. Her lab works on plant disease resistance and mycotoxin management and on circular economy for organic resources, with a special interest in resource recovery from sanitation to agriculture. From 2000 to 2021, she served as scientific director for the McKnight Foundation's Collaborative Crop Research Program, a grant-making program focused on supporting smallholder farmers' agroecological transitions in Africa and in the Andes. She's worked at the International Potato Center in Lima, Peru, and at the International Rice Research Institute in the Philippines. Rebecca received her bachelor's from Swarthmore College and her PhD from the University of Washington. She was a MacArthur Fellow from 1996 to 2001. Hi, Rebecca. How are you doing today? Welcome to the show.
Thanks so much, Abby. I'm doing great. How about you?
I'm doing wonderful. We are so happy to have you on the show. We are going to be talking about the biological circular economy?
Something like that. We're calling it the circular bionutrient economy, but there's a lot. There's many ways you could call it.
Circular bionutrient economy. I will try to remember that for the rest of the show. Fingers crossed. Hopes not super high.
Abby. The rest of your life.
Yes. I will endeavor to remember this and re-listen whenever things start getting foggy. But to get us started here, before we launch into the science, you have kind of an interesting career path that got you both your work as a plant pathologist as well as your work with the McKnight Foundation. So can you tell us just a little bit about how you got to where you are today?
Yeah, sure. So I was trained as a biologist. My parents are both biomedical people, and I was a big rebel going into agriculture. I always wanted to be an ag researcher. And I always specifically wanted to be an international agriculture researcher, working on food security. And so I trained up as a biologist, and I didn't really know how to coming from a medical background, I didn't know how to find my way to agriculture. So I got a pretty basic training, doing molecular genetics, and made the big jump when I was a postdoc. So I went off to the International Rice Research Institute. I felt that was a lucky break to get to do that. Spent 8 years there as a rice pathologist. And from there, moved to spend 5 years at the International Potato Center as a potato pathologist, looking at potato late blight there. And then my husband and I thought maybe our kids should get familiar with the United States. So we moved to Cornell about 20 years ago, where I joined the plant pathology department here at Cornell. And at that same time, I took up that job with McKnight Foundation as scientific director for their international crop research program, and really that kind of gave me that feeling I was still engaged with international agricultural development, working for smallholder farmers and stuff. So I'm actually now finishing up my last week in that 20-year run working for McKnight, and I'm thrilled and delighted to be able to, that was a wonderful job. I was super honored to have that role. It's great thing to do, and I love wonderful team. But now I'm thrilled to be demoted to grantee, or not demoted, promoted, whatever. I'm really looking forward to getting into the trenches as to work on this subject of the circular bionutrient economy. So I got into this idea because in the early 2000s, as a plant pathologist, I was in Africa, and people were dying of mycotoxin exposure in Africa, in Kenya. This aflatoxin outbreak was happening, and that kind of, as a plant pathologist, I was like, wow, a plant fungus that's killing people, that sounds like something I should be taking interest in. As a maize pathologist, I'm working on corn, and specifically it's corn, corn that's getting moldy corn that was killing people with this aflatoxin problem. So that kind of got me into this topic, because when the plants get stressed because of soil and climate stress, they become vulnerable to these fungi, which produce these toxins, and that kind of got me into this idea of working towards sort of this one health, healthy soil, healthy plant, healthy people, healthy planet, not exactly in that order. But.
Sure. And just for people who might not be aware, can you give a brief overview on what the McKnight Foundation is?
Yeah, the McKnight Foundation is a family foundation based in Minneapolis, Minnesota, and a lot of their grant making is local to Minneapolis, to the state of Minnesota. They have arts programs, they have, family, they work on families and climate, energy. So about 9-10% of their programmatic work is for international crop research. So I had the honor of working with the program, and until this week, as a co-director together with someone at McKnight on this international crop work. And so we've been supporting now 3 regional communities of practice, one in the high Andes of South America, and then one in West Africa and one in Eastern Southern Africa. So supporting really multi-stakeholder type project teams that together form regional communities of practice, working towards agroecological sort of transitions to have more sustainable food systems in those regions.
Sure. Well, thank you for doing that. Obviously, very, very important work. So moving on then to the circular bionutrient economy itself. I know that when we talked in preparation for the show, we kind of described, you alluded to this already, this kind of one health concept of everything being linked together, which comes up on our show a lot. But you also mentioned these different loops of scale, I guess. So I was hoping you could go into more detail about just in general, what is your one health concept and how that kind of you probably already touched on this of how it developed, but then also what are the different loops that you see in this circular economy?
Yeah, so thanks, Abby. I got to say that I think before thinking of loops, let's think of what we're doing now first. So think about how the food system works, right? We produce food mostly through agriculture, and we produce food, based on a lot of fertilizers, to grow that food. And the nitrogen fertilizer you make using, petrochemicals, and so it's got a high carbon footprint to make the, nitrogen fertilizer. Then the phosphorus we get by mining it, that's running, there's only a few of those mines, and they're, it's not going to last forever. That's sort of a known issue, this peak phosphorus issue. So, the price of these NPK, these soil nutrients is really going up strikingly now, and it's, probably heading in that direction. So we've got a sort of unsustainable fertilizer industry. Then we make our food, we eat it, and we sort of think of farm to fork. Well, the food system doesn't really stop at the fork. It actually enters our body and it comes out of our bodies, and then that what comes out of us we're sending to the wastewater treatment plant, and then so that's going, we're expecting that the environment then to just absorb that, so if it goes insofar as it goes into the water bodies, that we have eutrophic, water bodies, harmful algal blooms. We have, if we landfill some of the results of that, that's got another greenhouse gas cost associated with landfilling organic matter. And just, if you think about it, you're pulling carbon and nutrients out of the countryside dumping them into cities, into us, and then from there into the environment. And, I see the sanitation system's kind of a little on the ropes. You've got, every time there's a flood, in New York City, there's, overflowing with sewage. Germany, a lot of Europe was just, knee deep in sewage recently. When the power goes out in California, all the sewage goes into the ocean. You can't swim in the summer because, the power went out because people were running their air conditioners in some horrific heat. And then, 2-point-something billion people don't have proper sanitation anyway. Almost half of the world doesn't have proper safe sanitation. So, we just can't run that disequilibrium forever. Like a lot of African soils are completely depleted for carbon and nutrients, and then the water bodies are full of those carbon and nutrients that people need. And you have water hyacinths, you can't even go out and fish because there's giant water weeds in the way and harmful algal blooms and so on. So, the circular economy tries to tie that circle back together, send those nutrients back where they need to go. So we need to put that carbon into the soil to maintain the protective base. Soil carbon's, it's the engine of soil health. It's important for nutrient cycling and for water holding capacity of the soil. So, we gotta. So if we send those carbon and nutrients back where they came from into the soil, it would be a much more sustainable system. That's sort of the circular economy idea in general. Can we reuse plastic, reuse fashion, electronics, don't landfill the rare earth elements that you need for your electronics, reuse them, so on, keep things in service a lot longer. So if we think of our organic nutrients from our bodies, we have, they're sort of low value and high volume. People produce a lot of pee every day. Everybody produces a lot of these materials, and they're not extremely valuable. We want to upcycle them. So if you're, for example, if you're in an informal settlement in some, low resource neighborhood in some big city, Nairobi, Dakar, whatever, you could use those nutrients on a really small cycle way, use an ultra local nutrient cycling possibly. So I'm really fascinated by the idea of what would it take for us to turn the solid waste, human solid waste into pure carbon, biochar, pyrolyze it, and then use the heat from the pyrolysis to dry it and make that an efficient process. And then you could just dump pee onto some, low quality organic material such as cereal residue. So I was just today rushing over from setting up a 500 straw bale kind of theme park over at Cornell Farm, where you're trying to get our pea cycling campaign going, where we're just taking pea from dormitories and us locals and just dumping it right on the bales. I've done that for a couple of years now, and you can grow vegetables in that. That's like a raised bed. So straw bale gardening is a thing, but people sometimes use conventional fertilizers to turn that that carbon of the cereal residue into compost by adding conventional fertilizer. But NPK is in our pea and water too. So it just produces nice compost to just dump pea onto the straw bale. It doesn't stink. The microbiome makes ready work out of that and turns it into a nice growth medium for plants. So we're kind of setting up we just set up kind of a big array so we could upscale our pea cycling campaign. Not that this is an urgent place to do it realistically. We don't have serious water problems here. It's been raining practically every day. And, we don't have serious, we've got a nice wastewater treatment plant that does well. And, our lake has got its harmful blooms and whatnot. That tends to be blamed on animal agriculture. So we should do the same thing with animal nutrients as well, rather than throw them into the lake. So, but then we also want to be able to move those materials at some point back to the countryside where, most of agriculture takes place. So there we probably have to develop a more conventional fertilizer idea. We're still interested in this idea of turning the solids into biochar, capturing the nutrients from air and onto that, and then producing a more conventional fertilizer. So, we'd like to collaborate with the fertilizer industry to do that, maybe shift from the current paradigm to one that, and the fertilizer industry is indeed interested in making that shift towards more circular economies and more sustainable sourcing. So I have the privilege, the questionable privilege questionable that I've merited, but I appreciate the opportunity to participate in something called the 17 Rooms thing, which for the 17 Sustainable Development Goals. And I'm lucky enough to be in Room 6, which is about SDG 6, which is a Sustainable Development Goal about sanitation and water. And so there I'm in this small room with people from the fertilizer industry, from the sanitation field, and some from agriculture, myself included, to sort of look at how can we, reconceive sanitation from kind of dealing with a problem to dealing with a resource, a really valuable resource that we really need to use for, to produce, to loop back into the food system.
Wow, that's really promising work. That's really cool. Yeah, I think work like this is so interesting. So that's kind of the regional or very hyper local scale. But then you also mentioned that there's also more of a regional scale and then also a global scale. Can you describe what those look like in your mind?
Yeah, that's where the regional one is where, it's really, instead of just a neighborhood, like the tight scale is, you've got someone who's kind of collecting from this container-based sanitation scheme in their neighborhood and, using the straw bales or whatever it is to, composting the material or making their local little biochar thing. Then the thinking territorial is think of the city in its rural environment, thinking of the territory as a concentration of population in a landscape that includes the landscape that feeds that city, the countryside. And so if we're able to scale this up and handle that same nutrient recovery scheme in a way that either works with a conventional sewage scheme or, in my dreams, gets away from a water-based scheme into a dry sanitation scheme in which you're not putting in fresh water. I mean, so much of the world doesn't have that kind of fresh water that it can be dumping it into the toilet. Don't have toilets, they don't have fresh water. For me, I really admire the Scandinavian separating toilet technologies. For example, we were lucky enough to get a donation from Separat, a Swedish toilet maker that produces, separating dry toilets. And that's a normal thing to use in Scandinavia. And I really admire what they're doing and thinking that's so much of a more logical way to handle the problem than what we do. So in Kenya, too, like there are a couple companies that do separating dry toilet work, and we're also collaborating with an organization called Sanitation First in India, that they've got thousands of households using separating dry toilets. And again, that material is already source separated. It's not a stinky technology, and it's ready for immediate recycling. So that could be done on a local or a territorial basis, city within its region. And globally would just be the big fertilizer industry, right? So if this big fertilizer industry would, in a sense, be solving the sanitation challenge for really, high concentrations of people, for example, in big, low-resource cities, parts of cities where you don't have enough sanitation, it's really a health problem. If the fertilizer industry were to look at that as a golden opportunity to collect, resources, then they're providing sanitation for purposes of, collecting material to produce fertilizer. I don't know. That's kind of the dream that I would have for the global industry. Of course, that's not the whole story. There's also the animal. You've got, big animal feedlot opportunities to collect a lot of waste, but there's lots of places with lots of people who can really use help with the sanitation thing, and can see that as an opportunity. And so this is, to a certain extent, could be regarded as a new idea. To a certain extent, can be regarded as an extremely old idea, right? So this is sort of how we function before this wonderful bubble of, the oil era, which is just approximately my lifespan, right? Where, before, I'm 60, and so about 60 years ago, suddenly, everything was all about petrochemicals and, the wonder of modern fertilizer and mechanization stuff. But before that, people are recycling their nutrients. Like in China, for example, that's how they kept feeding a large population for a very long time on, night soil and so on. So I think we can look back on some of those historical technologies and figure out how, with the new tricks and, public health measures, we can do it in a way that's neither gross nor dangerous or anything. It's so that's why we're thinking biochar. Once you've gone through that thermochemical transformation, solid waste, while it's extremely dangerous stuff, keep it small and then convert it. Why throw a bunch of clean water in there render it a vast mess, dump your stormwater there and swim in it, like why would you do that? It's valuable, it's nasty, turn it into pure carbon and get it out to the field where it belongs, So the French have launched this idea of 4 per thousand. If we can pull that carbon into the soil where it's actually doing us a lot of favors, take it out of the atmosphere where it's trying to kill us, we could get there. And so then, where do you get that carbon? And where do you get that nitrogen that it takes to turn carbon into soil organic matter? Well, I think we can guess what I think the answer is. So, there's a lot of carbon just from farming, right? All that cereal residue. The plant has taken its NPK, all the protein, out of the plant and into the grain. We take that grain to the city. That leaves all that cereal residue as pure, carbon, basically. And then bring that NPK back from human waste, turn that into soil organic matter. It's a formula we ought to try.
Hi, everyone. I hope you're enjoying the show. Interested in hearing more from Rebecca? She'll be one of the plenary speakers at this year's annual meeting. Each year, the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America host a premier scientific international annual meeting. Come join us. Convene with thousands of other scientific leaders from industry, government agencies, and academic institutions this year in Salt Lake City, Utah, November 7th through the 10th, or virtually, wherever you feel most comfortable. The Society's annual meeting is the premier opportunity for professionals working in agronomic, crop, soil, and related sciences to hear about the latest research, meet and learn from their peers, expand their knowledge base, and take advantage of networking opportunities to enhance their careers. Visit acsmeetings.org to learn more. If you are a certified crop advisor or certified professional soil scientist, you can take a quiz for continuing education units for this episode, which can be found in our show notes or on certifiedcropadvisor.org. Let's get back to the show. Man, so much in there that I could spend hours diving into. I will hold myself back from doing so. One of the things that I was thinking about while you were talking, though, is I've seen a lot of papers come through our journals that talk about, manure or, other animal waste products. So what do you see, and less so about the more human side of things, where do you think the big stumbling blocks are for uptake of these kinds of approaches? Is it just a social, I want to flush something down the drain because that makes me feel it's more clean? Is it the actual, potential human dangers involved in sanitation? Is it just the technology isn't quite there yet? What are the big obstacles that you see?
Yeah, I think we have multiple enormous obstacles. I think the first one, I think we would probably all have to agree, is that sort of socio-cultural ick factor thing, which is really deep and it's well-founded. I understand that when the medical establishment did a giant survey and said, what is the biggest public health, smash hit of all time? What's our biggest contribution ever? And modern sanitation was the overwhelming winner of that survey. So the way the history of sanitation, the great success was the sort of flush and forget sewerage that solved, the old problems of, things being super disgusting and super dangerous because fecal matter is really, really dangerous. So the taboo that we have around it is very well founded in the fact that it's extremely dangerous stuff. So, and then again, billions of people don't have that now and have the consequent burden on their health and well-being. And it's also gross, it's just disgusting and stinky. So, that smell is a serious problem. So that's the first thing, is that people don't want to even talk or think about it. So it's sort of like not okay to even talk about it. And I kind of feel like, okay, the fact that it's taboo is sort of why it's like low-hanging fruit that we can actually harvest now. There's a reason we haven't been dealing with it. We don't want to deal with it. So if we woman up, man up, person up, and deal with it, there's just a lot of benefits we can reap. So I think that then, of course, we have gigantic, to the extent to which we've dealt with the problem, we have a huge sunk investment in that technology that's been so successful. And I sort of feel like it's a lot of things about sort of modernity, modern fertilizer, modern agriculture, modern sewage. These are all things we got to revisit now as our climate and our planet crumble. It's like, I'm not criticizing that last cycle of incredible innovation that led us to where we are. I mean, I honor those innovators, those innovations, but it's not the solutions that work for them are not the solutions that work for us now. We are in a special moment now. We have to take stock of what is that moment. What is it calling us to do? And frankly, I think it's calling us to basically reinvent everything to make these circular economies. Again, electronics, construction, fashion, plastic, everything. We've got to do it different than we've been doing it. And that means reinventing all those things that we live on and do and how we do it. So I think the circular economy idea has given me a ton of hope. But, billions of dollars in every big city that's been put into modern sanitation, that's not going to turn around easily. So our group includes architects, because they're looking at circular building. They're looking for new building materials that don't have such a high carbon footprint and high tax on the environment, are more reusable and stuff. But I'm trying to get through to them. They also need to think about redoing the plumbing. When I think of plumbing, I think you have a certain plumbing in your body, the way that your circulatory system and excretory system works is sort of the plumbing of you. That means the plumbing of your house. That means the plumbing of your municipality. That means the plumbing of the natural world, the rivers and lakes. And it's all plumbed now wrong. We have to replumb it, so it goes back to the field, the cornfield that fed you.
Sure. All right. Well, I think that's actually a great transition then into kind of where we are right now. You've talked a little bit about some of the research you're doing right now at Cornell, but I know you also wanted to talk about some of the earlier pioneers in this kind of research, the work they're doing, other larger initiatives. So what's the current state of this kind of research?
There is a lively research around resource recovery. I'm always a little bit sort of disappointed that a lot of it's focused at the wastewater treatment plant. And I think there's a logic to that because that's where the material goes. But it just bums me out that, urine's like 3% of wastewater, 2%. And yet it's the majority of the nitrogen that you're trying to recover. So why don't recover it at source? So I feel like a lot of the work that's done is really brilliant and everything, but it's being done sort of too late in the system for my taste. So I think I wish we would look really hard at how to, redo that plumbing, separate so one of the people in our 17 rooms, the sanitation conversation that Brookings and Rockefeller are supporting is, she's working in the Stockholm sanitation thing, and they're really working now to separate gray water from black water, so that you don't want the water from your dishwasher, your shower, your sink, kitchen sink to be flowing into your sewage. Keep the black water, the sewage, into one pipe, and the gray water another. You want to recover the heat from the gray water, and you want to recover the nutrients from the black water. So if we would just separate the pipes and treat sewage more carefully, and then for me, if we could separate again the urine from the fecal matter. So again, such separating toilets exist. I mean, our bodies are spatially distinguished the one from the other, and therefore it's not particularly tricky to use a toilet that allows you to separate the two. And then again, you can use the urine because it's practically sterile. It's not literally sterile after it's been out and about, but it's very close. It's not considered a hazardous material, whereas fecal matter is distinctly hazardous material. So, why not? I think the art of circular economy means source separating things as much as possible. If you're dealing with food waste, which I think should also be considered in the mix, right? How do we recover the highest value possible from food waste? Well, if you could separate your different kinds of food waste, your orange peels have a bunch of valuable features that, is not true of, they're distinct from what you want to do with your coffee grounds, perhaps. So the more you can segregate materials early on, the better. And so I would just hope we would segregate them. I forget, Abby, if I'm answering your question.
No, I think it's good. I had questions about current and future research, but I feel they're a little bit one and the same. So I'm just going to let you keep going and open the field a little wider. Just about, where are we going with this kind of research? obviously separating out different kinds of waste is one big initiative, but where else are we headed, or what progress have we made in any of that? I want to know it all.
Okay, cool. Well, one thing is that if I just reflect on who's on our squad, it kind of speaks to the kind of the multifaceted nature of the challenge. So teamed up, I think my closest partner in this matter is Johannes Lehmann, who's a soil scientist and a kind of well-known name in the biochar area in particular. So he knows this stuff in a way that I'm never planning to soil science and these matters. And he's very accomplished and has a lot of the pieces in place to take this game to the next level. So that's kind of one thing is this technology that could take us to the next level or for source-separated resource recovery. So that there's a sort of very hardcore technological thing, and we're just hiring postdocs that we hope is going to advance that in our team. And in that area, we've also got a engineer. Matt Reed is a civil environmental engineer guy who's got a background with some of these issues. And I first heard about him from Sasha Kramer, who runs Soil, which is a source separating toilet company that operates in Haiti. So Sasha graduated, I think, Stanford, and then went to Haiti. For the last decade, she's been running this organization that does a lot of this kind of work, provides sanitation, separating sanitation, and produces fertilizer from the solid waste. But their technology is composting the solids and dumping the liquids because, again, it's too heavy to lug the pee around. And so she herself acknowledged we were at something called the Urine Summit early, when was it, last year sometime, or early this year. And she expressed regret that she's not able to, at this point, to harvest the nutrients from the urine. So again, developing the technology that make that possible. So, we've got engineering and soil science teaming up together. And then, now we've also got a squad that's on the pea cycling side that involves public health people. So Kate Dickett is on our public health program, and she's teamed up with a grad student who are organizing the pea cycling campaign. Because, how do you get people to think and feel differently and then act differently? How do you get people to do what it was a transition for us to recycle our, plastic or glass, whether or not we actually are is another matter. But, but the habit of not tossing it in the trash, but rather taking care to make sure that what you use comes to the right, or at least as much as you can control it goes to the place you think it ought to be going. And that we start feeling that way about our bodily products too. It's not flush and forget, but no, I'm trying to direct this resource where I think it should be going, which is into the soil. And then teaming up with international partners in India and Africa, how each of those contexts is really different. How do you work, again, with how people think and feel in these different places, and then what they do, and then what's the technology that's right for that context. So we're my top colleague now on this in Africa is a guy named Charles Minega, who's an entomologist, and he's really interested in food waste first and foremost, and sort of the human waste would be a secondary thing once he gets his black soldier flies turning the food waste into fertilizer and animal feed, then human waste could enter that value stream. And I think, interestingly, particularly because of Johannes Lehmann's interest in sort of science and art, we're also kind of bringing there's an artist element to it too, kind of helping kind of challenge ourselves and kind of revisualize and reimagine our relationship with, in the circular bionutrient economy. And so there's a couple of artists that are kind of working with us from their angles, and it was really interesting perspectives and events planned. And so, we plan also to go to and also craftspersons. I've got a guy who's like an artist in wood who made this sort of futuristic kind of a rocket ship shaped porta potty, and that's going to be part of our straw bale array. Kind of invite people contribute and see this in a different way. Once you participate by using this porta potty, you're exposed to the type of technology of the toilet, you're exposed to the idea, you're contributing to this garden, and so can that now go to our local music festivals that are, events that take place in New York City, and then, Burning Man, one of the principal scientist for Burning Man is one of our team members as well, and he's got an interesting toilet technology, and he's interested in also this straw bale technique. You get 100,000 gallons of urine coming out of, this event in the Nevada desert. There's an adjoining ranch where, hopefully that material can hit a bunch of straw bales and just upgrade the soil on the fly ranch. So I don't know. We got that sort of combination of different kinds of scientists, from social science to hardcore technology people, and then artists and sort of community members who also sort of take an interest in the health of the lake and, sustainability generally. And then these craft persons that help us make, reinvent stuff. So.
Oh man, I love so much of that. First of all, I didn't know that Burning Man had like a chief scientist type position. Wow, that sounds like a very interesting person to talk to.
Yeah, he's fun. Yeah.
Yeah, I bet. Gosh, wow, yeah, and art is so powerful. What a great thing to harness for your cause and really help change people's minds. I imagine that's a huge step in the kind of social aspect of all of this. Make it a little more appealing to talk about for people. So this has been such a good conversation. I have enjoyed this thoroughly. Just so many cool ideas and things. I just want to do a billion Google searches on all this stuff. I have 3 questions left for you, though. First of all, if people want to learn more about any of the things that we've talked about today, where can they go for more resources? Obviously, you will be one of our plenary speakers at the annual meeting, so another quick plug for that. But where else?
One of the resources I recommend is the website of the Rich Earth Institute. And that is based in Brattleboro, Vermont, and they've been working on pea cycling for a long time, and they have a lot of good facts and figures, and just they've figured out how to pea cycle on a community basis. So I think that's one of the things I've found to be inspiring. And another entity that I've found to be inspiring is it's actually a farmer organization in Niger, like hours outside even the capital of this country, that is one of the most resource limited in the world, in the Sahel, where, the climate change is clobbering them worse than anybody. So the leader of this farmer organization, a few years ago, I think it was back in 2012, he was asking himself the same question I'm asking myself: where are we going to get this carbon for our soil? Where are we going to get these nutrients that our plants need? And he did an inventory, and he didn't come up with a whole lot of alternatives. And urine, urine was one of the few things he could get on that list. And so he was talking with a soil scientist who encouraged him to go down that path. And he did. Only a few people were willing to try it initially. And by now he's got thousands of farmers that are, fertilizing their millet crops with their family's urine. So these are like women's fields that the women have to feed the family, and yet they're not typically allocated the best fields. And so they've been able to show and collect significant amounts of data, now have publication on showing that improved yields that they've got with their urine fertilization. And so I found that encouraging, and they have some nice films, admittedly made by my son, that you can find if you Google Fumagaskia, Fumagaskia, urine or something like that. You'll see some videos on how they're doing it there. I found that to be inspiring. And then, it's one of those issues that's got, a lot of information out there from a sort of an engineering perspective, sanitary engineering. So depending on the particular aspect that you might find interesting, there's lots of publications about any aspect of it. So none of this is new news. There's a lot of change that we still need to make, but it's not like some, bright idea that has no track record. There's a lot of evidence that, these nutrients are good for plant production and whatnot. So, and then we're going to get our website up soon, so we haven't even gotten out. Our Soil Factory Network project is quite a new one, so we're pretty poorly documented, but hopefully we'll get some resources up there for the public soon.
Sure. Yeah. Once you have that up, please send it to me. I'd be happy to add it to our show notes.
Oh, fantastic.
And put it up on our Twitter. So, okay. So then what is the next step for people who want to then get involved with any of this? Obviously, there is a wide range of opportunities for involvement. So what are a few first steps people could take?
I would love it if, because we're trying to, I feel like this social networking aspect, like networking amongst ourselves, is really important. So I would love to hear about anybody who's keen And then how, what's entry-level pea cycling look like? If anybody feels like doing it, entry-level pea cycling to some extent looks like, lug a jug, pea in a cup, put it on your garden, and, if you, dilute it 8-1 or something, it's quite safe as a fertilizer for your yard. And then, put up a straw bale. That'll take, at least several, 8-10 gallons of urine, just at the rate you can produce it. If you just dump your pea on your straw bales, you can have yourself a raised bed, with little cost. That's another entry level thing. That's what I'm trying to practice, that entry level. And then, we'll be working on the technologies that others are too. So I would love to hear from anybody who's got an interest and then we figure out how to make common cause. There's a group at UC Davis, for example, who's doing this kind of work. And I've been touching base with them, Harold Leveran. So I was inspired to see what they're doing. Everyone's got a little different angle. So I think we're all just collectively trying to find the way. And the more people that join, the faster and better we'll find our way, and the more difference we'll be able to make.
Sure. Yeah, that's great advice. I will make sure that we have links for all of the things you've been mentioning, as much as I am able to find them and track them down. And we'll definitely have contact information for you as well. So if anyone would like to reach out to Rebecca, please do. I'm sure she would love that. Final question. What is one fun fact that people would not know about you if all they had was your research?
I guess even the fact that I'm interested in the circular bionutrient economy may not be obvious if you look at my research, because it's always been about like maize genetics and stuff like that. So, I realized at some point that the best way to solve the mycotoxin problem was through soil health. But until then, I've been working on, grain sorting and genetics research. So this is a new thing for me. But, also another fun fact, maybe, I don't know how fun it is, but when I was a kid, I was living in suburban Maryland, Bethesda, Maryland, and against zoning laws, I was a goat herd back then. And so just as many people might be out about with their, pet dog or whatever, I was out there with my pet goats. And so I think that just revealed my early interest in being an Aggie. And, and sort of, my dad is from South Dakota. He's a researcher at the National Institutes of Health, but I knew I knew to have a weak spot for the agricultural interest. So when I lobbied for goats, I knew he would eventually succumb to my campaign. But yeah, and also that idea of maybe peri-urban agriculture, raising food where it's not obvious that that's the right thing to do. But I still feel like I would love to bring, food production to people in maybe the suburbs is maybe not the word, but peri-urban areas where maybe those cereal residues could meet that tsunami of pea that's poorly managed now, get it where it belongs.
Wow, those are some lovely fun facts. Thanks so much for a lovely conversation. Thank you for taking time out of your busy schedule, setting up your hay bale wonderland you've got going on over there. And we look forward to hearing from you at the annual meeting. Thank you so much for being on.
Thanks so much, Abby. And if anyone's out there listening, greetings to you, and thanks for tuning in.
Thank you for listening to Field Lab Earth. You'll find links to today's resources in our show notes or on our website. If you have any questions, comments, or recommendations for show topics, please contact us at podcast@sciencesocieties.org or on Twitter @FieldLabEarth. If you'd like to hear more content like this, please subscribe, and don't forget to rate and review us on Apple Podcasts, Podchaser, Stitcher, or anywhere else you find your podcasts if you like our show. This podcast is a joint production of the American Society of Agronomy, Crop Science Society of America, and Soil Science Society of America. Special thanks to Lobo Loco for the use of their song Spook Castle on the intro and outro of our show. Opinions and conclusions expressed by guests are their own and are not considered as those of the American Society of Agronomy, Crop Science Society of America, Soil Science Society of America, its staff, its members, or its advertisers.